Hey everyone, welcome back to week 2. Hopefully everything from last week made sense and you guys have some good kind of creative ideas that are bubbling underneath and you're excited to get those rolling. We're going to start talking about some of that stuff today as we transition from getting our kind of initial orbit satellite system built into starting to put elements in there and kind of start to fill in those blanks a little bit. So hopefully you all are up to speed at this point because we're just going to pick up where we left from last week. So the next thing we're going to want to do is we need to get this Earth doing its thing, right? Because obviously that needs to be a pretty central focal point of this thing. Right now, let's look at how small that Earth is. It's pretty tiny. If you remember, I made this thing a uniform scale of 0.1, which I don't think that's going to work so well. Let's try 10. Let's just merge that in here really quick and see kind of what the relationship is. I'm not looking for accuracy necessarily. I'm really just looking for the relationship to the Earth from the satellites, right? So that Earth looks a little big to me. Let's maybe go like 7 or probably even go to 5. That feels a little small. Let's go 7 again. I like 7. Okay, so I'm going to stick with that for the moment. Again, the great thing about this is that we can totally change it later if we want. That's kind of the awesome thing about working in Houdini. We're not locked into anything. Okay, so we've got our Earth in place, but at the moment it doesn't have any textures on it. So let's solve that problem. We're going to go in here. I'm going to actually change this from polygon to a polygon mesh so I can get kind of these latitude and longitude lines. That's just going to help me align things and make sure that our projection is working okay because I more or less know where the equator is supposed to go. So let's go ahead and crank up these rows and columns. I'm going to go 200 on the rows and 500 on the columns just to get a whole bunch of points because I'm just going to use a point attribute because whatever we're doing here is really just for reference anyway. Like what we're doing here isn't necessarily going to actually render. And if it were, I probably would be treating it differently. It's really just as a guide. So we need some UV coordinates. I'm going to use a UV texture SOP. I'm going to throw that in there. And we want this to be a kind of spherical mapping, if you will. So we're going to use the polar texture type. And we're just going to leave everything else default. I'm going to throw in an attribute from map node. If you haven't used that, it's super handy. It really just kind of creates a attribute from a texture map, so you don't have to do it via VOP or whatever. So what I've got is a series of Earth texture maps, and I got them from this website, which is super handy. You can totally buy these. I grabbed these forever ago, so I've had these Earth images kicking around for a long time. But you get like a bump map and a spec map and city lights and all that fun stuff. So pretty cool. And like I said, I'm really just using this for reference, so I don't need this to be super accurate just yet. We'll use it again when we actually make like a proper Earth texture. But for right now, we're just going to keep it simple and use this as a reference point. Great. So we've got our Earth in here, and I want to start rotating this Earth. There's a couple of different ways that we can do it. In the past, I've chosen to do this with an attribute VOP, but you can do this the old school way, which would just be using a transform SOP and a little bit of H script if you want. So this is one way to handle it. So we can throw in our transform node, and let's call this rotate. And here in the rotate Y axis here, this is where we're going to put our H script. We're just going to put $T, which is time. That's the variable for time. Now, if I just leave that alone, it spins pretty slowly. So I want to multiply that up because that's going to, like, you're just never going to see that. And I want to make sure that it's clear to the audience that this is the globe and that we get like a nice spin to it. So we can actually just take this and multiply this, say, times, I don't know, times 10. Let's see what that gives us. That's a little nicer. I'll leave that alone for right now. The attribute VOP way, and you could do this in a wrangle as well, but whoops. We could do this with an attribute VOP. Again, we're going to use our old buddy, the transform matrix VOP, this guy, except this time we are actually going to use the P, the position. We're going to plug that in over here. And you know, just like with the transform node, we're just gonna animate the y-axis offset on the rotation. We're going to do that using time, so we can plug time in, except time is a float, and this rotation is a vector. So what I need is a float to vector, so that I can only plug it into the y-axis. I don't really want to plug it into anything else. So we're going to take the output of time, we're just going to plug it in there. And again, that's going to give us that really slow rotation, way too slow. So we need to multiply that up a bit. I'm going to throw in a multiply, and I do want to multiply it by a constant, but instead of multiplying it by a constant value in here, what I want to do is promote that value so that I can use it as a slider up above. So what I'm going to do is middle click on this and just say promote parameter, and I get that little tab. So I'm going to click that. I'm just going to change this label. I'm going to call this Earth speed. Cool. So now up above, I have a slider called Earth speed that I can change, and we could set that to 10 as well. And you can see that that's going to give us the same kind of rotation that we would get over here on the transform SOP. So same thing, just a different approach. Now, the reason I kind of like the attribute VOP approach is because I get a slider. That's really the only advantage to doing it this way. There's absolutely nothing wrong with using a transform SOP or even programming some vex if you wanted to program like a quaternion rotation or something like that. These are just easy ways to do that. So the other thing we want to do, we want to start including those geosynchronous satellites in this rotation. So we don't want to just rotate the Earth. We want to rotate the Earth and the geosynchronous satellites, which are these guys out here. So let's go ahead and merge those together like this. And now we have our Earth, which is way too small, and our geosynchronous satellites. And if I hit play, you can see there go our satellites. And we know that it's also rotating the Earth at the same speeds, just obviously our satellites are considerably further away. Now, those satellites are way too far away. There's you know, this is perhaps more physically accurate to the scale that we're dealing with. We're dealing with, you know, thousands of kilometers. But for our visual purposes, design-wise, it doesn't make any sense at all. The Earth is a speck, and that's not going to do. So what I'm going to do is come back up here to my attribute wrangle, where I set this p-scale value. Now, if you remember, this p-scale attribute is going into our copy to point SOP, which is the thing that's actually copying all of our orbit paths. So when we adjust that p-scale attribute, we adjust the overall radius of all of those rings. So I'm going to take this down. Let's try 0.01. Let's see where that gets us. That's a little better. It still feels pretty small. And you know what? Maybe what I do is up the scale of the Earth, because I don't really want to go too much smaller than 0.01. We're getting in a decent size here. Let's scale the Earth up to 10, and we'll do some other scaling as we need to. But for the moment, that's probably okay. So let's hit play. Let's see that Earth rotate. Yep, there's the Earth and all of the geosynchronous satellites rotating around, which is awesome. That's great. So next, as you kind of saw, some of our scale is a little off at the moment, and I want to start kind of wrangling some of that in and starting to see all of these things together so that we can sort of figure out where things really need to fit and all that stuff, so that we can start thinking about our composition overall. So I do want to give a group to my Earth points. We're going to call this Earth PTS for Earth points. We're going to give another group to our geosynchronous satellites. We're going to call this Geo PTS, Geo points. I can probably ditch this. Let's go ahead and drop a group on the output of all of these, which from last week, if you remember, this is all of our low Earth and medium Earth orbits. We're going to call these, let's call these LEO, MEO. And let's do this. Let's call them, instead of PTS, let's make that a little more clear. Let's call that SAT PTS, just like that. Copy that. Let's go over here. We're just going to do the same thing over here, just to make that a little more clear for us later. Or anybody else, you know, if anybody else were to jump into this project, they could pretty clearly go back and follow the group names and everything. Okay, so we have our Earth, we have our geo points, we have our low Earth and medium Earth orbit points. Super cool. And we have our orbit lines, of course. Now, we don't really need the orbit lines for our geosynchronous orbits, right? Because those are locked to the Earth. We could have those if we really wanted to, but they're not going to be, the ones that we have up here are not going to work for us because this isn't really the orbit that they follow. Remember, we set these up as a function of that inclination attribute that was coming from our Excel doc, and we really just grabbed the point on here where that longitudinal line was, so that we know where it is in space, but it's like it's totally fixed to the Earth. So these lines actually don't work for us for orbit lines, because then your satellite wouldn't be following the orbit line would just be kind of spinning on the y-axis. So we actually don't need those at all. So I'm just going to get rid of this merge node, and I'm going to link up this color SOP and our orbit lines. We're just going to stash that over there for the moment. And sat points, we are going to use that, but just not yet. So what I'm going to do is, whoa, that's not what I'm going to do. I'm going to throw in a merge SOP. Here we go. And we're going to merge in our Earth and our Earth points and our low Earth and medium Earth orbit points. And I am going to hook this up for the moment, but what we need to do is delete. We need to delete out our Earth, because Earth is not a satellite point. So here's all of our satellite points. And before that, let's look over here at our merge. So now we can kind of evaluate everything all together here. Now I did make that Earth a bit bigger from before. So originally I had that at a scale of 7. I made that a scale of 10. And now I feel like these low Earth and medium Earth orbit points, they might just be just a little too close to the Earth. So I kind of want to go back and scale those up. So I'm going to go back up to this attribute wrangle. And while I'm up here, you know, I'm going to change the name of this attribute wrangle. We're going to call this attribute wrangle radius scale. Whoa, there's an E in there. There we go. Anything that I find myself interacting with on a fairly regular basis when I'm designing these things, I'll usually go back and fix that name, or anything where there's like a key piece of information that that I may need to go back and adjust. A lot of times I won't personally go in and like change the name of like every single delete SOP and every single little attribute VOP and everything, but like if I find myself going back to it, chances are somebody else would need to as well. or, you know, if I crack open this project a year from now and I can't remember what I was doing, it would really be helpful to have some nodes that are named. So I'm going to go in here. Let's scale these up. Let's try, I'm just going to try 0.1. I think that's probably, that's okay, actually. I don't mind 0.1. That's giving me a pretty good distance around the Earth, because what I don't want is for things to get too crowded in there. It's going to get very, very busy. Personally, I really like a really dense kind of aesthetic, especially for the key focal point of this thing, which is going to be the Earth. And so I know that I'm probably going to design in a lot of density right in here. And I don't want these little satellites to get too terribly close to that. Plus, you know, when you're dealing with you know, feature film, FUI, and that kind of thing, you're not usually going to get called out on accuracy. Like if we wanted to be fully accurate, this probably wouldn't work very well as a visual. So we're going to go with something like that, but we can always adjust that later. Great. So now we've got our Earth, we've got our points. Let's wire in our orbit lines. Let's just have all of these things here together. Now, I will admit that I have, when I'm in this kind of stage of the design process, my workflow tends to get a little sloppy, a little fast, because I'm trying to iterate really quickly. I'm trying to get a groundwork laid so that I can move really fast into the design phase, because I don't want to spend all of my time working out all the technicals. I want to start making something that's a little bit more tangible. So my process tends to be a little fast at this stage, and then usually what I'll do is I'll go back and I'll clean up as needed. So that's why I'm doing things like just wiring everything into a merge node and kind of ignoring the fact that I've got a little error here that's telling me that I have some mismatched attributes, which totally makes sense because I've got attributes coming from all over the place. But what I care about is seeing all of these things in one place. So now I can see all these things. I feel like these orbit lines are actually probably detrimental because they're hard to see. Maybe I'll template them. There we go. Okay. So I can see my orbit lines. I can see my satellites. I can see that everything is moving. I've got my geosynchronous satellites sitting. I've got the Earth spinning, and I've got all of my low Earth and medium Earth orbit satellites going, which is so cool. That's great. The one thing that does kind of bum me out at the moment is I've got these couple of extra rings that are way, way, way out here. I don't really want those. Those are coming from my low Earth and medium Earth orbit satellites, and it's really this delete SOP right here. This number needs to be lowered, because remember, this is the distance culling that we're doing essentially. So we're preventing any of these like super big Earth satellites from entering into our design, at least at the moment. Like I said, we might go back and we might change that. I'm going to see maybe 7,000 will be low enough. I just want to get rid of those outer ones. Okay, that's better. I don't mind this one. Like this big guy is kind of cool. I just didn't want anything like way out here, at least not yet. Okay, so that works pretty well for me. We've got our all of our satellites. You can see all these little points sort of going along their orbits. We've got the Earth. Yeah, this is looking good.